Every picture tells a story. We're going to start with number 1, and let's see where we're at. Can I have a volunteer to read this, please? Yes, nice and loud.
May made 50 flyers for 5 volunteers in her club to hang up around school. She gave 5 flyers to the first volunteer, 18 flyers to the second volunteer, and divided the remaining flyers equally among the 3 remaining volunteers.
Beautiful. If we have a word problem, I think the best thing for you guys to do is actually to read it twice. First time, just read it once to yourself so you get an idea. Now let's read this at the second time around, but let's pause at the first period. Another volunteer to read just the first sentence. Yep.
May made 50 flyers for 5 volunteers in her club to hang up around school.
Period. Stop right there. Let's dissect this. You have a tape diagram there. Okay, you have a bunch of rectangles with some numbers, some variables, and then you got that bottom 50 over there. What does that first sentence describe? What part of that tape diagram does that first sentence describe? What part of that tape diagram does that first sentence describe? Yep. Got it? Got it?
Describes the total amount of flyers.
Excellent. It describes the total amount of flyers. So this 50 is my 50 total flyers. Alright, so I'm expecting you guys to label this. Expect this. Now, you have a tape diagram. I'm going to give you a tape diagram on a quiz or an assessment, and I'm going to say label each component. Okay, that 50 in the first sentence is my 50 total flyers. Next, she gave 5 flyers to the first volunteer. Comma, stop. What does that part represent? What part of my tape diagram is that one? Yep.
She got rid of the first 5 flyers and gave them to the volunteer.
Okay, so this 5 right here in this tape diagram goes to the, it's 5 flyers to the first volunteer. First comma, second comma, 18 flyers to the second volunteer. I'm going to take that one. Good. 18 flyers to the second volunteer. That 18, the next 18 in the tape diagram is the 18 flyers. Second volunteer. And then, what do those X's represent? What does that, or what does that next sentence represent? Yep. Right here. What does the X represent?
It represents the remaining flyers.
Yeah. Each one of these X's represent the remaining flyers. Divided equally. And my last question for you guys is, what does each one of these cells represent? Or rectangles represent? What does each one of these cells or rectangles represent?
The remaining flyers that were divided equally among the remaining volunteers.
So the X's are the remaining flyers, but what does each one of these rectangles represent?
It represents the separate amounts for the different volunteers.
Yeah, the different volunteers. All right, each one of those rectangles represent a different volunteer. First volunteer got 5 flyers. The second volunteer got 18 flyers. The third, fourth, and fifth all got the same amount of flyers, denoted by X, X, and X. What if they got a different amount of flyers? Would I use X, X, and X?
No.
No, I'd probably use something like X, Y, Z, A, B, C, any other three different variables to show 3 different quantities. Questions? Yep. Questions? Okay. The second part is, after we label all this, is we want to solve for any unknown quantities. What's the unknown here? What's the unknown? Yep.
The X.
The X, and what does the X represent?
The X represents the flyers.
The flyers that went to the last 3 volunteers. All right, so that's what we need. All right. What was our total? Or actually, how many X's are there right now? 3. So let's say hypothetically I have $30 and there's 3 of you guys. How would I divide those 3, or how would I give, or spread out those $30 between 3 people? How would I spread out those $30 between 3 people?
I know the answer.
Divided by
3.
3. What if I had $60? How would I split that between those 3 people? Divided by 3. What if I have $90?
Divided by 3.
Excellent. So no matter what, I'm looking for a total. I have 3 x's. I divide by 3. So far, so good?
Yes.
So I need to know what the total of those 3 x's are. Do I know the total of those 3 x's yet? Is there any number on that tape diagram that gives me a total of 3 x's? No. Right? There's nothing on that diagram that gives me a total of 3 x's. Do I know what the overall total is?
Yes.
What's the overall total?
The overall total is 15. Find the 3 x's to take away 5 and 18.
So let's start there. So my overall total is 50. So I'm going to start with my total. I have 50. I'm going to subtract my first flyer, or my first person that had 5 flyers. Then I'm going to subtract the second volunteer who had 18 flyers. And then what's my new total after I subtract?
27.
Yeah, I'm going to get 27 remaining flyers. Now I have 27 remaining flyers, and I want to give it to my last 3 volunteers. Yep.
You would divide it by 3.
Excellent. So I'm going to take this 27 flyers that are remaining, and I'm going to divide by 3, and 27 divided by 3 is
9.
9 flyers. I have an answer of 9 flyers, but I want to be able to do this by creating an equation. So at some point, I'm just going to give you the paragraph, and I'm going to say solve. I'm not going to give you a tape diagram. I'm not going to expect you to label the whole tape diagram. I want you to go from the paragraph, or the sentences, to an equation, to a solution. What kind of equation can I start with? What do you think?
You can start from the thing, but like you do 50 minus 18 minus 5, and then the x's and that is put up.
Okay, so you're talking about the process, right? We're going to do 50 minus 18 minus 5, yes, but the equation to start with would be what?
You would do 5 plus 18 plus x plus x or plus 3x.
I love it right there. So I'm going to look at my tape diagram. The 5, the 18, the x, and the x all will equal 50. So let's write that down. 5 plus 18 plus x plus x plus x all equals 50. That's a big long sentence there that I can actually shrink a little bit and make it a little smaller. 5 plus 18, what does that equal? I don't have to write 5 plus 18 separately, I can write it together. Yeah, so rather than writing 5 plus 18, I'm going to write 23. 1x plus 1x plus 1x is going to equal 3x. So 23 plus 3x equals 50. There's my equation. Before you can solve an equation, you have to be able to write the correct equation. Now we know the answer is going to be 9, so how do we get this 9 from the equation? So I have 3 volunteers represented by my 3x, all getting the same amount. So at some point I want to divide by 3, just like we did to get the 9 here. But I don't want, how do I get to that point where I just divide by 3? Yep.
You would do 50 minus 23.
50 is my total flyers. Excellent. 50 minus 23. So 50 is my total flyers. I want to take away from the total flyers the flyers that were given to the first and second volunteer. Well, how do you get rid of a positive 23? What's the opposite of positive 23?
Minus 23.
So I'm going to subtract the 23 here so I could cross that out and simply write 3x. But since this is an equation, and life has to be fair, if I subtract 23 from the left side of the equation, or the left side of the equal sign, then I have to subtract 23 from the...
From the right side, so 50 minus 23 equals 27.
Beautiful. So now I have 3x equals 27. What does that mean, 3x equals 27?
It means that those 3 boxes, they all equal 27.
Okay, the 3 boxes equal 27. Let's see if we can throw the words flyers and volunteers in there. How can we try to put it in those terms?
So it's like 3 remaining volunteers, and the x is what is the amount that was
Perfect.
assigned to you.
The 3 is the remaining volunteers, and each volunteer gets X amount of flyers. So X is the number of flyers that the 3 remaining volunteers. So 3 times X equals 27. 27 is the total flyers that the 3 volunteers get. I don't want to know what 3 volunteers get. I want to know what 1 volunteer gets. So how do I get rid of this 3? This is 3x or 3 times x, and the opposite, like you said, is dividing by 3. 3 divided by 3 is 1x, or in this case, 1 volunteer will get x amount of flyers. Yep. What I do to one side, I have to do to the other side to keep it balanced. Divide the left side by 3. 3 divided by 3 is 1x. Divide the right side by 3. 27 divided by 3 is x equals 9 flyers each. Do I have to write 1x? You could just write x, so I'm going to get rid of that 1 and just write x equals 9 flyers each. Now I wrote x. X is just any random variable. Do I have to write x? Can I write a, b, c, d? Can I write any variable?
You can write any variable, but for this problem you have to write x because that was the variable.
Cool. What if you were creating your own? Would you still use an x, or can you use something that might make a little more sense? Anything you want. What would you use? That might make sense for this one. Yep.
You can use like F.
I like F for flyers. Yeah. What are we talking about? We're talking about flyers, so let's use an F for flyers rather than an X for flyers. And again, it's completely up to you, but sometimes if you put a variable with the name, it might be easier to solve.